Saxon Advanced Mathematics, Lesson 95. Students, this is a straightforward lesson, 2 examples. Most of the work that we're going to be doing is calculation. It's just kind of straight, it's not even algebra, kind of. We're using our trig skills, but we're really focusing on numbers. Complex roots is the topic. We're just making it a little bit harder. And let me show you the problem, and I'll remind you of what we already know. I'll write it out. Okay, here is a number. It is a complex number. It has a plus bi form, right? So we know it's a complex number. We're supposed to find the the 4 fourth roots of this number, okay? So there are 4 different numbers that when multiplied together will give us this, and we're supposed to express it in polar form. Now this is a nice hint, because we know that to find, oh my gosh, I cannot write today. To find complex roots, we need to work in the polar form, okay? That is a general rule of thumb. To find complex roots, we need to work in the polar form. This is not the polar form. Now, what is polar form? How do we know polar form when it hits us? Now, we have used this, right? This is what we use as polar form. But this is for real numbers. And remember, hashtag means numbers also. And we learned quite a few lessons back that we don't use this same presentation style. We get the same information, but we don't use the same presentation style when we're talking about complex numbers. We say m times cosine plus I times the sine, right? We write it like that. This is polar form for complex. Okay, so remember, it's the same information, right? M is the hypotenuse, N is the degrees of the angle. It just looks really different in that presentation. So this is rectangular. We need to switch it to polar, and then we'll find the roots once it's in this form, and I'll remind you of the steps of that. This is confusing because they look so different, and so we feel like, what? I'm so confused. I don't know what we're doing, but this is the very same thing. It's the very same information, just using different symbols to present it. So I'm going to take this 6 plus 4i, and I'm going to convert it to something. This will be the hypotenuse. CIS, and then this will be the angle. All right? So the first step I have to do is draw the triangle. All right, well, it's going to be pretty nice. It's going to be a first quadrant angle, I know, because both of those are positive numbers. So it's going to be 6 here, and I'll put about 4 there, and that's where our point will go. Then I draw my line coming out. Draw the triangle. The 6 is in the right place. I know that this side is 4 because I measured it right there. I just moved the 4 over here so it's on my triangle better. And I'm going to need to find this side, right? I'm going to call it H for hypotenuse, and I'm going to call this A for the angle, okay? Now, we've been doing this for a long time. Just because this started with a complex number, this process is exactly the same. To find the hypotenuse, I'm going to use the Pythagorean Theorem. Already sorted out for me, right? And so this will be h equals the square root of, this is 36 plus 16 equals what, 52, right? And if you grab your calculator, which you are allowed to do for this, you'll get that this equals 7.21. Okay, you can work in 2 decimal places. All right, so I'm going to put that into my picture, and I know that that is going to go right here, 7.21. Okay, now we need the angle, just like we do whenever we're converting rectangular to polar, we can use tangent. The tangent of angle A is, tangent is over Arthur, so that is opposite 4/6. Okay, so again, you can use your calculator, and what you'll do is you'll enter 4 divided by 6 equals, and then you'll use the second key, and you'll use the tangent of -1, and that will give you the degrees to tell you that A is 33.69 degrees. Okay? Because in this example, we know the degrees and we know the decimal and we want the degrees. That's when we use the inverse, is when we know the decimal, or in this case, the fraction, but we quickly convert that to decimal in our calculator work, and we want the degrees. That's when we use that button, and we have to hit second to get it, to find it, okay? So now we know that this is a 33.69 degree angle. Okay, we have successfully converted it. So we use Pythagorean and tangent to find polar form. Okay, now we're ready to take the roots. Okay, for the hypotenuse, in this case, we're finding the 4th root. We take the hypotenuse and we find the 4th root of it. We cannot do that by calculation. It has to be the calculator. And the way that works is we find the button. It should be X, Y, like this. So we enter the X value, 4, then we hit this X to the Y key, and then we enter the Y value, which is 7.21. That's the sequence that you use. And the way your calculator understands this is the first value that you enter is the X, then you press the function key, then you follow it with the Y value, okay? So this is the way your calculator is understanding the information that you're entering, okay? When you do that, the value that you get will be, just a second, the 4th root of 7.21 equals 1.64. Okay, so now when we write out our roots, which I'm going to do here, let's see, 4, 3, 2, 1, they're all going to have this for the hypotenuse. Okay, that's the same, that doesn't change. The angle is where we have more work to do, but I can write the cosine plus I times the sine of, I can write that right away. Okay, that's just setting up the format. Now, to find the angle, what we do is we take the angle and we divide it by 4, and that gives us the first root. First root. Okay, so in that case, we take 3369, we divide it by 4, and that gives us 8.42. That's our first one. For the additional roots, we take 360, we divide it by 4 because that's how many roots we're finding, and we get the number 90. So we take this much and we add to get additional roots. I'll let you catch up before I race us on. Okay, so the first root I got by taking our angle and dividing it by the number of roots we wanted, right here. 33.69 divided by 4. That's what we get. That's only for the first root. Now I'm going to add 90 once, twice, 3 times to get our additional roots. So this I can do in my head. This is 98.42. Then this will be 188.42. And then this will be 278.42. And these are all degrees. These are our angle measurements. Okay? Whew. What's different this time is that our numbers are a lot trickier. Before everything came out smooth and even. But the steps are the same. And so let's practice it one more time for 95.2. I'll do this one just a little bit faster because all of the explanation was provided for I did all the background work. Find the 5/5 roots of -17 minus 14i, and we want the 5th roots. Okay, express the roots in polar form. Okay, so we do not have to move them back to rectangular. Saying express the roots in polar form is great news. So we know that we want to say something, CIS, something. This is going to be the hypotenuse, and this is going to be the angle. I want you to start writing this out every time because I think it will help you know what the heck you're doing. All right, so this is the important first step. Identify the way you want to reshape this point, this value, so that we can do it. Because we can't take the powers, or the roots rather, we can't take the roots in this form. We have to get them into this form in order to do that, okay? The way we do that is to draw the triangle. I can see this is going to be in the 3rd quadrant because everything's negative. I'm going to go negative 17 here, and then I'm going to call this 14. I guess I'll do it like there. These are negatives and negatives, right? So our point then goes about here. Then I draw my triangle back up to the the x-axis. That's always how it goes. And I know this is 14 over here, right? Same difference. So I need to know the hypotenuse and I need to know the angle. The hypotenuse I get from Pythagorean Theorem. H equals the square root of 17 squared plus 14 squared. The numbers are getting crazier, right? You use your calculator to work this through and you'll get H equals 22.02. Let me know if you have any problem with calculating these. Now to find the angle, we're going to use tangent. The tangent of our angle A equals the opposite 14 over the adjacent 17. Okay, I know that I can enter 14 divided by 17 equals, I'll get a decimal number then I'll use the second and the inverse tangent key to find out that A equals 39.47 degrees. Not 47, 47. 39.47 degrees. Okay, we're getting close. Now I'm gonna set up my roots. 1, 2, 3, 4, 5. I know that my hypotenuse is going to be divided by the number of roots I'm taking, which is 5. Oh, no, I'm wrong in that. This is where we take the root. We have to take the fifth root of that. So we have to find 22.02 to the fifth. So we use that x root of y button. We put 5 in, then we'd hit xy, then we'd hit 22.02, and we will get 1.86. Right? 1.86 is the number that you multiply by itself 5 times to get 22.02. Only your calculator can tell you that. So here are all of our hypotenuse roots, right? They always stay the same. And that's the fifth root of 22.02. Now we need to find the angle. This is where we divide by 5. We take the, oh, I see what I did wrong. I see what I did wrong. Ooh, I caught myself on a good mistake. 39 is just this much of the angle, right? But in order to find the proper polar value of that angle, I have to add 180, don't I? I didn't do that. So this equals 219.47. Make sense? So this is 219.47. Right? I forgot this. My bad. All right. All right, now that's much better. Now we take 219.47, we divide that by 5, right? For the hypotenuse, we take the root. For this one, we just divide by the number of roots we're finding. 219.19 divided by 0.47 divided by 5 equals 43.89 degrees. That's the angle of the first root, right? And this is what's interesting to me, is that the hypotenuse of all the roots is the same, but the angle changes. So to find the other angles, we take 360 and we divide it by the number of roots that we're making. And that is 360 divided by 5, that would be what, 72? Yes. Okay, so now we're gonna start adding 72 to this value, and that would be 115.89 degrees, and then 72 more would be what, 187? 180, yes, 187.89 degrees. And then 72 more would be 259.89 degrees. Usually this addition is fairly easy. You can do it in your head. And then 72 more would be 331. Okay, if you can't do that in your head, that's fine. Just keep adding, right? We would take 43.89 and we would add 72 115.89, and then 72, right? You can easily do this with paper. So feel free to do that. These are the 5/5 roots of that original number written in polar form. If we wanted, we could convert these back to rectangular coordinates. We would just have to find the cosine and the sine of this degree angle, which we could do using our calculator. It's a lot easier when these are values that are on our unit circle because we've got all the answers right in front of us. But we could do this using our calculator quite easily. We'd find the cosine of this number and we'd multiply it by that. Then we'd find the sine of that number and multiply it by that. Same thing here. We'd find the cosine of this number, multiply it by that, then the sine of that number and multiply it by that. That's if John asked for rectangular coordinates, but he didn't. He said leave it in polar form. So these are the hypotenuses. Hypotenuses. This is the hypotenuse for each of them, and this is the angle of each of our 5 roots. Oh my gosh, that was exciting and weird, wasn't it? I hope this makes a little bit more sense. I will definitely have a problem like this on the test. So talk to me, ask me if this is still confusing to you. Great job. 95 is done. Goodbye.